Hello and welcome to this class. For today, we're trying to understand the concept of dimensional analysis, right? What is dimensional analysis by definition? Dimensional analysis refers to a method or technique of showing relationship between physical quantities, right? So dimensional analysis refers to a method of showing relationship between physical quantities. That's dimensional analysis, right? For dimension refers to how physical quantities relate to the fundamental quantities by definition. So I have actually defined dimension only for you. Now define the concept behind dimensional analysis, right? It's a method or perhaps a technique of showing relationship between physical quantities, right? So look up. Let's say I have three parameters at random. Let's say I have three parameters at random. Let's say I have force, and I have mass, and I have acceleration. Look up. I want to explain this concept. Let's say I have these three parameters here: force, mass, acceleration. We need these three parameters. What is the relationship? From Newton's second law of motion, we know that force is equal to what? Mass times acceleration. True or false? Yes, true. So from here, force is equal to ma, mass times acceleration, which is true. So now, let's say I don't know the relationship. That the relationship is force is equal to mass times acceleration. Let's say I'm just giving this type of parameter. Is there any way of getting the relationship such as this? Yes. You see the concept of dimensional analysis, right? Let's say I'm given four parameters at random again. Let's say I'm given R, resistance. I'm given rho, density. I'm given rho, density. Let's say I'm given length and area. Within these four parameters, there's a relationship between them, right? So what's the relationship here? The relationship here is that R is equal to rho L over A, right? So rho is density times length over area. So let's say that I don't know that this is the relationship, right? Is there any method of knowing the relationship if I'm given all these four parameters? Of course, yes, there's a method of knowing the relationship, which is what? Dimensional analysis. Look up, let me show you something. Let me show you something. Alright, let me show you something. Look up this. We said force, pressure P is equal to force over area. I want to drive something. Look up this. Pressure is what? Force over area, right? From Newton's second law of motion, force is equal to what? Mass times gravity. True or false? True. Put in mg. So it means that force is what? Mg, right? Put mg into this. So I have that pressure is equal to force. What's force? Mg. So I have mg all over area, right? With respect to density, we said density is what? Rho is equals to mass over volume. Make I have one here. 1 times m is m is equal to rho times v is rho v, right? Rho v. So from here, anywhere I see m, I'll put rho v. So from here, pressure P is not equal to mass. Mass is what? Rho v. I'll have rho v next to G all over A. I have A here. At this point here, but volume is equal to area times height. Volume is equal to what? Area times height. How? You know that volume is measured in meter cube, right? So meter cube is actually gotten from meter square times meter. Meter square. Whenever you do the word meter square, what comes to mind? Area comes to mind. So I have area multiplied by meter. What comes to mind? Height. So I have height. This is how volume is gotten as area times height from dimensioning. So for me now, volume is equal to what? Area times height. So whenever I say volume, I put AH. So that means pressure is equal to rho next to V. Volume is what? AH. I have area and height next to G all over area. From here, area cancel area. From here, pressure now P is now equal to rho H G. This is a very important formula when it comes to pressure, right? So the relationship between this parameter, pressure, rho, height, and G is what? Pressure is equals to density times height and gravity. Let's say I'm not given four parameters at random. Let's say I'm given pressure, I'm given rho, I'm given height and gravity. Now, I already know that the relationship is what? Is this one. Let's say I don't know the relationship as this. Is there a method of knowing the relationship between these four parameters? Yes. The idea is what? Dimensional analysis, right? So let's take a sample problem and alright, let's start with example one under this concept here. Alright, example one says the pressure of a fluid depends upon the density of the fluid, comma, the acceleration due to the gravity of the fluid, comma, and the height attained by the fluid. Full stop. What is the relationship between this parameter? So I'm saying that pressure depends upon the density of a fluid, that's rho. I mean rho, density of a fluid, that's rho. And also depends upon, or perhaps, density of a fluid, the acceleration due to gravity, that's G, right? And the height attained by the fluid, that's H. So the question that says, what is the relationship between this parameter? Now look up, please. Before we start solving that question, first task is that when it comes to dimensional analysis, the least parameter we given, right, is 4, maximum 4. In some cases, might be 3. So in this case, I'm given 4 parameter. What and what? I'm given pressure, density, rho, and height, right? I already showed you the relationship, which is this, right? So let's say I don't know that this is this. I want to use the method to confirm if our relationship is correct. So it means that from here now, I'm giving maximum model 4 parameter. Note that for a level, we'll be giving maximum 4 parameter. But in some cases, in some rare cases, you'll be given 3. So you can't be given 5, right? So now in this case, when you are given 4 parameter, what do you do first? For that question there, your first task there is to list out the given parameter, right? What are you given? First task, list out given parameter. In that question, I'm given that the pressure of a fluid, I'm given pressure, so that's pressure. So first task there, I'm given pressure. So pressure, that's P is equal to, now look up. Your first task is to list out parameter. Now whenever I list out parameter, list out the parameter and its dimension. Right, in the last class, we did dimension, it's only on its own. Dimension, right, dimension, last class. And we said dimension is what refers to how so quantities relate to parameter quantities, right? In our last class on dimension, we derived the dimension for pressure. What's the dimension for pressure? That's the dimension pressure is mLT to the power minus 2. That's for pressure. Next up, in the question, I'm given what the pressure depends upon the density of the fluid. I'm doing density there. Density, that's rho of the fluid. What's the dimension of density? That's mL to the power minus 3. That's for density there. Now try to watch our last class on dimensioning to understand the idea behind this one here, dimension for density and rho. We did all this in the last class, right? So I'll drop the link in the description of this video. So try to check the link, right? So for there. Alright, from here, I'm also given acceleration to gravity, that is gravity, that's G. What's the dimension of gravity? Gravity is what? Is measured in meter per second squared. That's L T to power minus 2. That's the dimension of gravity. Next up, also given what the height. That's H. That's what in. That's L. That's these are the dimension for each given parameter. So I'm giving this parameter 4. Let's get the relationship between these two parameters. First task, list out the parameter and its dimension. When you are done, in mathematics, I represent dependent. For every question under dimension analysis, one parameter will depend on the other, or the other will depend on one. Check in that question which one depend on which. In that question there, I'm hearing that pressure depends upon density, gravity, and height. So it means that this pressure here depends upon density, gravity, and height. Per se, you can say that the rho, the density, the gravity, and height depends upon the pressure. Now, when it comes to mathematics, how to represent dependent? I use what? A direct what? Proportionality sign. So it means that we're saying that pressure P depends upon, having represented that pressure is directly proportional to rho, gravity, and height. What's the next task? The next task is to put what? A superscript, right? So I have that pressure is directly proportional to what? Rho, put x here, gravity, put y here, and height, put z, right? YZ. So I have this one here. So next task is that in mathematics, how do you take off the proportionality sign? You introduce what? Equal to a constant k. So I have that pressure P is equal to k rho x g to power y and h to power z. Next task. So now at this point here, always assume that k is 1 at this point here. I'll assume that this k here is 1. In some cases, k value might be given, but if not given, in this case now it's not given. So assume that k should be 1. So at this point here, let k to be equal to 1. If k is 1, it means that pressure P is equal to density to power x. Next up, gravity to power y. Next up, h to power z. All right. At this point here now, introducing dimension, right? At this point, or input dimension. At this point, I'll input dimension. What's pressure? What's the dimension for pressure? That's what mLT to power minus 2. I'll have mLT to power minus 2. All right. Next up is now equal to, that's for pressure. Density is rho. That's mL to power minus 3. All encased to power x. That's for rho. This is a dot. This dot means multiplying. I have gravity. What's the dimension for gravity? That's LT to power minus 2, then to power y. Finally, I have for h. What's h? As L, or to power what the z. At this point here, expanding, right? Let's tax here. Expanding. So if I expand, I'll have what? ML t to power minus 2 is equal to, from the idea of indices, there's an invisible one here. This is 1 times x is x. So I'll have m to power x. Alright, at this point here, multiply the power here. I'm having m, attach x to it. I'm having m to power x, attach x to it. Next up, L to power minus 3, attach this x to it. I'm having a dot here. I'm having L to power y. Next up, T to power minus 2y. Attach this y to it. Next up, I'm having dot L to power z. I'm having z here. At this point here, next task is to collect like terms, right? So collecting like terms, right? So I'll have that, putting this one back, m L T to power minus 2 being equal to first tax. I'm having MLT. Start with M. What's M? I'm having just one M here. Pick out M first. I'm having M first to power X. Next up, pick out L. I'm having 3L here. L, L, and L, right? So from the idea of indices, if like bases are multiplying, right? If I have up perhaps, I'm having L. Pick out this first L. L to power 3X. Next up, L to power Y. And this next up, L to power Z. Finally, I have what? T to power minus 2Y. From the idea of indices, if like bases are multiplying, simply add a power. So this and this and this are the same thing, multiplying. So add their power. I'll have that lt to power minus 2 is equal to m to power x dot l. These are 3l. Pick out one. Add their power. That becomes minus 3x plus y plus z for the power of l. Next up, I have t to power minus 2y at this point here. My next task here obviously is to what? Is to compare index. Look at the procedure. Follow the procedure and you're there. Next task here is what? Comparing index. So comparing index. To compare my index, I'm having, let's start with for m. For m, what am I having? What's the power for m here? That's 1. I have 1 to be equal to, what's the power for m here? I have x. So I'm here. That's my first equation, equation 1. First task. All right, we are seeing the word index. What's index? Is when something is very, let's say I have a to power b. This power here, you can call it power, or you call it index, or you call it degree. So this b, you can call it what? Power or index or degree. So I'm saying now, comparing index. So I'm comparing the power. 1 is equal to x for m. Now for l, let's do for l. For l, what's the power for l here? Is 1 being equal to, what's the power for l here? That's minus 3x plus y plus z. Call this what? Equation 2. Next up, I have for t. For t, what's the power for t here? That's minus 2 being equal to, power for t is what? Minus 2y. So I'm here. So I've gotten, this is my what? Equation 3. Equation 3. All right, at this point here, I haven't gotten equation 1, equation 2, equation 3. All right, I haven't gotten equation 1, 2, and 3. Right, next task is to what? Solve equation 1, 2, and 3 simultaneously. Right, so it is very clear that equation 1 is telling me that 1 is equal to x. So it means x is equal to 1. Right, from equation 1, from equation 1, x is equal to 1. That's very clear. Also, my next task is to pick equation 3. From equation 3, from equation 3, what's equation 3? It says that what? Minus 2 is equals to minus 2y. Let's get y here. Of course, minus cancel out minus. First task, I'm having what? 2 is equals to 2y. Divide both sides by 2 to get y. 2 cancel 2 here. I have that y is equal to, all right, from here, we're saying that y is not equal to, this y here is equal to 2 over 2. 2 divided 2 is 1. Therefore, y is equal to 1. So I've gotten the value for y and x, right? X is 1, y is 1. Let's get value for z. So to get the value for z, we recall from equation 2. So from equation 2, which is what? 1 is equal to minus 3x, next up, plus y plus z. At this point here, put x to be equal to 1 and y to be equal to 1 into equation 3. Or perhaps, what's okay, equation 2? So this equation 2 here, I'll put, anywhere I see x, I'll put 1, and anywhere I see y, I'll put 1, as we had here. So it means that 1 is equal to minus 3 into, what's x? X is 1, plus, what's y? Y is also 1. Next up, plus z. I have my z here. This z. So it means that 1 is equal to, minus 3 times 1 is minus 3, plus 1 plus z. From here, all right, I have that 1 is equal to minus 3 plus 1. Minus 3 plus 1 will give minus 2 and plus z. At this point here, there's a mistake here. What's the mistake? Check back. Our pressure, the direction of pressure is m L to power minus 1, please. There's a minus 1 here. Get it for minus 2 from the idea of pressure, right? So L to power minus 1. There's a minus 1 here, minus 1 here, minus 1 here, minus 1 here. So this L, we are having one minus 1 here for L, minus 1, and this one here. So for pressure is M L to power minus 1 to the power minus 2. So it means that in this case here, for this equation 2, this one here, I have minus here, minus, minus, and minus, please. Avoid the mistake, please. From here now, I'll take minus 2, right, into here becomes minus 1 plus 2 being equal to z. Minus 1 plus 2 is 1 being equal to z. So I have that z, perhaps, therefore, z or z is equal to what there is 1. So I've gotten the value for x, y, and z. So now I'll put my value for x, y, and z into this equation here. So I can call this what equation asterisk, right? So I'll put y, z, and x into equation asterisk. So my next task is to put the value for x, y, and z into this equation here. So P, pressure, is equal to density to power x, gravity to power y, and h to power z. Pressure here is equal to density. What's x? I have x to 1, x power g to power y. What's y there? Y is 1, and I have h to power z. Z is 1. From the idea of indices, anything or perhaps any number raised to power 1 is that value. So rho raised to power 1 is rho. So pressure is equal to rho GH. This is their relationship. Let's say we don't know, right? When I did the derivation, I have this. So when I use this method again, I still have the same parameter there. I have the same formula. So let's try to solve example 2 in the next class. So check this from this video. I'll drop a link or a next class in the description of this video, right? So these are to work on dimensional analysis.